Hey guys, welcome back to the shop. Hope everybody finds this video interesting. It was a big learning curve, so if anything, I'm offering everybody an aha moment. I did mess around with it off camera and did get a pretty good knurl out of it. And the nice thing is the walls to the diamonds are nice and shiny, whereas with the traditional scissor knurl you do not get that, and it does create nice sharp points to the diamond. And I did ask Tom with Ox Tool, I emailed him if he would make one or something, you know, give us an education on it. The big key though to getting it to work right is you do have to get the height perfect, so that each wheel is cutting exactly to the same depth. That was one, and the other one that I do mention in the video is trying to get both wheels at the same angle to work. So, hope you enjoy the video. Well, this project to me is going to be really interesting. Seen a bunch of cut knurlers on Google, YouTube, and so on, and knurling has always been kind of a pain. Well, in the beginning, what I learned was it's diameter specific, and there's tables and formulas, and I'd hit the diameter, and then you go and knurl, and it was still kind of a crapshoot whether you got a good knurl or not. And then a comment was left, I think it was on that video, from a German machinist saying, just force it in there. I did a video on how to do that, and that seems to be successful every single time. But you look at it under a magnifying glass and it's not really perfect, sharp points and so on. So I'm thinking that a cut knurler, the way it works, is going to give me beautiful sharp points like it came off a CNC machine or factory stuff. So did a lot of research. Here's the print that I came up with what I'm going to make. Got a nice block of material here, which should do it. The one thing was doing it this way, I can just put it in either machine because I'll just clamp on it. But I'd love to dedicate it to one machine or the other, because the old machine, my first lathe, has female thread, no, it has male dovetail, and this is the other one. No, that's female. Okay, whatever, they're different. So one has female and one's male dovetails. So if I did that, I'm stuck on one machine. So I don't know. Well, the other thing I've got to remember to do is distance, because I can only go so far back with the saddle, and so I can only do certain diameters. There's a limit to how much I can do. Hopefully this will get me further doing it. So all the research, as far as I can tell, this has to be 30 degrees because it's going to cut a 60-degree knurl point. And as far as I can tell, this guy gets rotated 5 degrees. So when this is in there, I'm going to do this angle in a collet block. And I'll set it down flat first, and I'm going to use this guy to just make a mark. I've already tested it. Where's the mark? Oh, there it is. You guys probably cannot see that. But it came down full force and just go back and forth. And I can fill that in with something black so it'll stand out. But that'll be my reference, because then I can tilt it and then do this 30-degree mark. So that's a 0-degree line. And then I'll have to do the same thing on this guy. I'm not sure exactly which way to rotate it, so I'm going to have to do a 0 line when I drill these holes, and then I'm going to have to angle it, which I should be able to do with just one of these blocks. What do I want? I want 5 degrees. Oh, okay, yeah. So I was planning on putting this on one side and then putting another 5 degree on this side, and it shouldn't slide. I should be able to hold it good enough that I can use this guy and just make my 5-degree marks I'll have to switch them. So I have a 0 mark, and I have a +5 and a -5, so to speak. So that's, this guy goes in there this way, I guess. So that's the plan. Got a lot of material here to cut off, but because this is a what? Yeah, it's a 1.7 by 1.5. So I got a lot of length to cut off, 2 inches. Geez, so I'll just be taking it over to the saw here, and yeah, I gotta cut like right here. All that goes in the scrap drawer for some other project. So. And then I figured 832 should be able to hold this guy. This is the 832, yeah. So I'll make a bushing in there, and that'll hold that. And then I'll use the 1032 to lock it in position. I'll do a counter bore in here, and I have to thread the back of it, 1032. So when I rotate it, I can lock it down. So I think I've got all the details here. Yeah, the way this thing is, I can slide it all the way back here and just even clamp it on 2. So I'll have plenty of distance between the material in there. And I know I got to raise and lower it depending upon the diameter of what I'm going to knurl. So I guess off to the bandsaw, and rather than you guys watching me cut this up, I'll let you watch my 3D printer go for a minute. Alright, so kind of big chunk came off. Throw that back in the inventory. Yeah, I made this note just to remind me to double check the distance. And I did draw this pretty much though to scale, especially because I wanted to see how much thread I'm going to have in here to hold these wheels. So now I'm looking at this going, yeah, 5.575. I'm pretty close to it. I'm at 6. Yeah, pretty much 6.5. So I gotta pretty much remove some material, and I'm gonna do it with the face mill. A lot better chip control than a fly cutter. Fly cutter gives a lot better finish, but when you gotta take some material off, that's the only way to go, and chips stay pretty much so under control. Then I'm looking at this going, I have to take this out, so I'm going to use a roughing end mill for the first time. Bought it a long time ago when I started the hobby, but never really used it. So what I'm thinking is, this one side, this looks like this has been through the saw, horizontal saw. So I'm going to put it in this way, face that off, then I can flip it over, face this, and then I'll do the other 2 sides. Bring it down to the width that I need here. What else to say on this print? Now I lost how I gotta do it. Oh well. It's yeah, it's that. It's all. That's a lot of material to come out, right? That's for that. That's supposed to be 0.6 deep. Always pick this ruler up upside down. 0.6, yeah, alright. Well, I'll redo this after I face everything off. Oh, here's the side with the cut. Alright, well, whatever. Yeah, it goes this way. Alright. What else is there to say here? I hope I have a counter bore for this head. How big is this anyway? Come on. Yeah, the video I did talking about calipers, that one caliper was off by 1,000. It just died for that video because I had checked something just before doing that video and it was spot on. It's been spot on for years and then all of a sudden off. So I bought another one because I like it so much, and this guy is right on with the Mitutoyo. 0.3, huh? Well, probably I have the metric counter bores, and I'm watching another set right now, a really nice set on eBay. I hope I get it too. I'll go all the way up in price if necessary. So let me go and just do some face milling, I guess. Let you guys see a little bit of the shop here and how I've arranged things. Okay, that's the side that I was going to do. Kind of the nice thing too is when I'm here, all my ER32s are right here, and the parallels. When I'm over on this machine, all the ER32s are right here. There's all the lathe stuff. And then here's all the mill tools, so easy to get to. The only pain is if I need a drill bit, I gotta move out of the way to get to the drill bits. So not that big a deal. Alright, so I'm gonna set this up for face milling here. Clamp him down, and there's a collet in there already. Probably the 1/2 inch. I always wind up leaving that in here. This is the precision one. Yep, that's the precision one. I can tell because it's really shiny compared to the other end mills. Alright, face mill. And they're all right here. And I want this guy right here. And that's probably... Nope, that's the bigger one, huh? Yeah. Big guy. So, I'm just pop him in there. Everything should be clean. Never really gets dirty up in there, which is nice. The nuts do get a lot of material in them, so I got to blow them out, clean them up from time to time. Little maintenance here. Alright, so he goes in there. Again, I just hand tighten this stuff. He doesn't go anywhere. That, bring it over. Close this up so junk doesn't go in there. Well, with this plastic thing you're going to see in a second, not much stuff flies all around. It stays contained right here. Easy to clean up. Come on, over. Faster. Yeah, bring it in more. Alright, so bring it down over further so it just about touches it. Lock it, and the plastic guy's right here. So, yeah, I gotta move the microphone. Sorry, I dropped you guys. But that's it. So, I'm ready to go with this thing. So I'll bring it back when I'm done. Roughing end mill isn't really doing a nice job. Teeny little chips, but I could run it across and I could feel like the cutter went back. And sure enough, I come back and it's taking just as big a cut. So no wonder I never used this thing. So I'm going to try this guy, which was the one I showed before with the high helix on it. Alright, which one does that fit? That's going to be metric. Pull him out. Oh yeah, this is the guy you can't grab with your hands because you get cut up. Get a rag and pull it out there. Alright, so this is going to be way down here in size, huh? Yeah, that one. hopefully this will do better. It only has to go down 600 thousandths, and it measured it, and it'll cut it, so. Yeesh, careful holding this thing. Alright, he's locked in position. I'm gonna figure out the depth here. Bring this over. And I need to, I can't see, huh? Yeah, I can see. Alright, so I want to be like right about there. Lock it. So let's see what this guy does, huh? Power back on. Oop, forgot to unlock it. There. Alright. I know this guy getting, yeah, see, it's just cutting at the bottom right now. It's not even cutting the top. So much for that guy. I guess I'll just keep him maybe for steel. Well, if he can't do aluminum, forget it. Oh, this is much better. I can tell it's not fighting it at all. So this is a great cutter. This was a, I know, a Banggood one. And again, I wish they had bigger. Oh, this is easy. Boy, this is taking material off fast now. Yeah, and a gorgeous finish to boot. Alright, so I need to do a bunch of cutting on both sides, leaving 400 thousandths in the middle to clamp on. Wow, these chips are crazy. Let me break the camera loose so you guys can kind of see what this is, huh? I'm gonna move it over there. I am absolutely loving this end mill. This thing will pile up chips faster than that roughing end mill. And I'm taking 15, 20 thousandths depth of cuts, which you just don't do on a mini mill. But I'll run it, do a couple of passes here, if I can reach around the camera. I mean, it's just taking, look at these chips coming off full length. And the finish is ridiculous. It doesn't do very good at all, conventional milling, but climb milling, beautiful job. Look how fast it piles them up. And you can't let it touch them because they're all stuck together and it just wraps itself all around the end mill. There's another, this is a 20 thousandths cut right here. The machine isn't vibrating, nothing, no chatter. Yeah, I like them so much so that I went back on Banggood and I ordered the whole set. And I'll put a link in the description for those interested. Big pile of chips. So, fantastic end mill. Tell you, that is one nice end mill. I really like that guy. That went through this pretty quick. What is that little mark? Oh well. Alright, nice having a print to scale too, because you can just sit this on top of it. Now the next dilemma is I want to use a 1/2 inch and I want to be turning down anything bigger to fit in there. And I know I'm going to have to turn it some, so I did find a nice, I think this is metric. Yeah, 12 millimeter. So this will work good. It's 0.471, so. And I want to use an end mill because I want to have a nice square bottom here. This part. This isn't center cutting, so I'm going to have to drill this hole. Oh, I never did put down what size hole this is in the print. And it's nice realizing your math is wrong. 0.587. I could probably do 0.590. 0.590, and then I can get rid of that. Did I do 0.6 in here? Yeah, I think it did. 0.6 deep. Whoop. Yep, 582, close enough for government work. Oh, it's a little bit shorter. Oh, and I still have to finish that off. Okay. So I got a little bit to do. Never did fly cut or face mill that face. So I gotta drill this all the way out, figure out what I'm gonna do. This is 1032 for a 1032. Alright, so I gotta measure one of those and say what size hole, drill this through. I'm not sure what I'm gonna use for the countersink yet, but then I can sink this in. Ooh, 1.5 inches. Yeah, I can go that deep, I hope. 1, 2, 3, 4, 5. Wow, just make it. So I'm gonna cut this shorter than probably 1.4. 4. Then what is that gonna leave me here? If I did 1.4, take it down. Oh, there, that's close. Yeah, that'll work. Because then I got a lot of room to countersink and everything. Okay, so better. Much better. Alright, so I guess off to figure out this and then drill that out. Oh, I'll spin the camera around too. A little thing that I've been working on my lathe here. There you go. I gotta replace the brake rotors on my car. And this sucker is huge and darn heavy, let me tell you. Bolts are so tight I gotta use an air, but I can't get in there with the hose on it, so I'm waiting for a 90-degree so I can get in there with the impact and get the bolts free on the brake calipers. How good the lighting is here, but I did the scrape marks with that tap holder, and they're pretty deep, but I figured, I bought these guys for the 3018, why not just use them here? So, I guess I gotta zero out the Z-axis here. I'm looking at the DRL, 0 set, close, and I want to lock this thing because I want them both to be the same depth. Alright, so I'm locked, and hopefully I'm set to go, huh? 625, yeah. So I want to go down in. Oh, it's already scraping it. So go down to what? Actually, I could come off the edge, huh? Alright, so I'm going down in. I'm going to come back and completely come in. And then on the DRO, I go to 0.7. Is where I had stopped before. 9, 8, 9, 9, 7. Let's see what that looks like. That looks pretty deep. Yep, that's pretty damn deep. Okay, so now I gotta go up. I'm at 0 for Z, so just come up a bit. And I gotta go over to 6. Oh, I don't care about 625. Here it's clearing. Okay. Alright. Go back down to 0 again. I'm up 24 thou. 3, 2, 6, 5, 4, 3, 2, 1, 0. Alright. So that should be the same depth. Yep, it's cutting it alright. And go all the way over to 8, 9, 9, 8, 9, 7. And then come back nicely. So that should be it. Now I gotta set it up for the angle to do that 5 degrees. How does that look? That doesn't look too hot. Let me try really high RPM. Clean up those sides some. Yeah, that's cleaning it up. I think you have to use this thing at extremely high RPM. Yeah, that's better looking. Alright, well, it's not as good as the other side, but or maybe it's just dirt in there. That might be. Alright, well, wow. Got one side of the car done. New rotor, new brakes. Oof, that is one miserable, very dirty job to do. You get brake junk all over you. Okay, so I did successfully drill all the way through and use the end mill. A smaller end mill went down in there. They're both the same depth, then came in with the 12 millimeter. Looks good. I'm very happy with this. Yeah, the hole turned out to be a 13/64 drill bit in there. Did the scratch jobs, but when I angled this thing to do the 5 degrees, it was so close that I just didn't even bother. I mean, it was going to even touch the bottom edge of the first scratch. I did CAD it on the computer, and yeah, it is going to be right there for this diameter hole. I used the gauge pin to find the center of the hole, and then looked at the angle, what was going to happen. So, got a gauge pin. Next thing is to turn this, so I know exactly, you know, it jams in the bottom here. Oh, now great. Now I got to get something in the other side to hammer that out. Right? Yeah, it's stuck. Okay, so I know what to turn this to, and I'm probably just going to do one at a time. So I guess off to the lathe, and let's see what happens here. Alright, here's where I am so far. And I decided to just see what the one wheel would do. So I'm going to give up on this. This is as far as I'm going. And I'll tell you why. One, I've had great success with this guy. So I think you've seen a bunch of the knurling that I've done. I'm going to build another one of those for these larger wheels. I've got a big assortment of different types and pitches and so on. But when I first put this in the lathe and tried it on just a piece of scrap, all I got was just a quick groove. So this thing cuts real quick at an angle. Studying it closely, I realized it's kind of rounded on the edge, and I wasn't really hitting the teeth on it. And the angle here, I'm way off on this dimension. This is way too short. I do have a little spacer down in there. I just found a junk thing to give me a little bit, make it poke out more. And I got that stuck great. Oh, come on. There, whatever. So, I'd have to remake it all longer, and I don't want to do that. But what I wound up doing then is I had to angle the compound, or, you know, the quick hinge tool post, so I'm more on the teeth. And then I just hand rolled this thing, and yeah, I was getting a pattern here, so it was starting to use the teeth. And again, it does cut real quick, so this would be a fantastic tool. But I did eventually learn that the two of these guys have to be synchronized, and for different diameters you have to have a different angle on it. You know, smaller diameters, it looks like in the one video I saw, you're more straight. The larger the diameter, the more you got to tilt both of them. So trying to figure out math, what angle is, nah, forget it. I'm not going to do that. So yeah, here's a quick knurl with that guy, and yeah, it seems like it works almost every time. Not almost, I mean every time I've done it so far, which is probably 8 different knobs or things I've made, it's worked perfectly. I've gotten a good knurl. So this is just gonna go on the shelf someplace. I did find another holder here. It was skinnier, so I just quickly machined this out, and I gotta deburr it so that it would hold this guy for doing this test. So what else to say? Yeah, I'll just put the print in the book, so maybe someday I'll come back and try to do it again. But I couldn't find anything that really tells you numbers, and the videos that I've seen where they're using one, it's a larger pitch. I mean, they're further away and they're deeper and coarser. So I'm not sure if this wheel would ever do it. But when I did the test, like I said, I just rocked it back and forth and I saw the pattern. And then once I rolled it, you know, twice, it's overlapping and it's messing itself up. So it's not staying. You know, I don't know where I did it. I did it twice, moving it to a different angle, and no, it's just, it can't do it. So again, I'm quitting, and that's about it. I did make the other piece, but I'll just shove this in the, since it needs to be a lot longer, I'll just shove it back in stock. Okay, I had given up on this thing, and I was going to put these wheels back in the drawer, and lo and behold, all the other wheels had sharp edges. So I figured, all right, let me try a sharp edged wheel. And I had set it for straight, and you know, like 0 degrees, no tilt, nothing, and it still slanted at a 45. But I'm looking at what it did, and it stayed within its track. In other words, it didn't start going over existing bumps and wind up making a groove. It made a perfect pattern all the way around, but the pattern was straight grooves because I was straight. So that the light bulb went on that the tilt on these wheels is simply making the tilt for the pattern. So that would be, I guess, 35 degrees. Well, that's what I measured this. These guys are 35 degrees. And then the light bulb went on that you're changing the angle, as in that video, not for the for the diameter, but as the diameter gets bigger, the angle has to change to keep it at a 35 degrees. This guy, the way it works, no matter what diameter it is, it's still doing 35 degrees. But the way this works, and look at the junk it takes off. I don't know if you guys can see that, but it cuts in one big hurry. So I did make the other piece and the bushing and all that, and I tried it out, and yeah, it's starting to work. So it's a matter of now, I'm just, because this video is getting long, I'm just going to quit. But yeah, I have to make sure they're at the same height. I've got to put in a screw here to adjust. I think I was off center, which is why one side wasn't cutting as deep. So, and then I've got to somehow get them synchronized, or some way of knowing that they're at the same angle here to play with. So if you guys want to build one, I mean, it does work, and somehow it does. I got grease and junk all over me. Somehow it just stays on track like this guy does when you dig in. It doesn't walk all over itself. The pattern doesn't travel. So that's it. Hope you guys enjoyed.